Okay, so we're going to get started here. Welcome to CMPT 394-858. I'm going to be your instructor for this course. My name is Nathaniel Osgood. I'm a professor here at the Department of Computer Science. Through this class, you'll come into acquaintance with many of my personal passions in the computer science area, which include the main focus of this class, characterizing systems in the world using simulation models, but also aspects of software engineering, language design, and other components that allow us to build those models with a special clarity. This class includes both an undergraduate, 394, and graduate, 858 class. There's a whole swag of chairs up here in the front if you'd like to make use of them. And it will be a very full class, hence the recent arrivals needing to sit up here. I will make every effort to make sure that each instance of this class is recorded and that as many people as possible get access to these machines to be able to follow along on the computers within this room, which will form a very important element of the class. So today's lecture, I really have three primary aims. The first of them is to give an overview of the class. The second is to provide you with a hands-on, concrete experience of many of the more lofty concepts we'll be talking about in this course. And thirdly, to get started towards, not fully deliver, on a lecture that helps you understand why it's so important that we use simulation for the types of systems we'll be talking about, with the added experience of having gone through a concrete example. So the objective of this course is to help students learn to appreciate and critique existing simulation models, to understand strengths and limitations of these models, and indeed of different types of modeling approaches, and to gain familiarity with building models using modeling software. And when I say model building here, just like with software engineering, it's a multi-stage process. It's not just one inchoate process. It's in fact can be subdivided into several articulated stages, including conceptualization of a model, where we anticipate model boundary and what's in the model, what's not, what's calculated by the model, versus what is what we tell to the model to assume. Model formulation, where we're specifying how that model is captured, and then model analysis and use. Okay. I also would like you to appreciate something about where the field is going and get some understanding of the very exciting frontier areas within simulation. And again, for anyone who's out there in the hallway, I saw some, there's chairs up at the front if you want to grab some up here, okay? Don't be shy, come up to the front and grab a chair. We're going to be like this probably through a lot of the semester. And I suspect there's even more people in the wings out there, okay? So I'm not going to go exhaustively through class coverage. There's a fairly detailed, in fact, very detailed list of this in the syllabus on Moodle, which many of you can refer to. But broadly speaking, we're going to be going through an introduction to modeling more generally, and then to three particular modeling approaches known as system dynamics modeling, agent-based modeling, and discrete event modeling that we can use to characterize complex systems. And when I say here complex systems, I don't mean merely systems that are complicated, that have lots of moving parts, although that typically is the case. I mean systems which exhibit surprising behavior, systems where the whole is in some sense greater than the sum of the parts. And that may sound like a fuzzy concept, but by the end of this class, you should have a very real sense of just how significant it is. There's many systems where, like with the traffic jam, to reason about the dynamics that change over time in that system, we can't simply reduce it to its various pieces, the cars, in isolation. We're going to be talking about the process of building models and introducing some hybrid modeling techniques, and talking about how these models capture various aspects of the environment, particularly in the agent-based context, which will be the foremost focus of our work. We're going to be going through some coverage of common tasks for all types of modeling, such as calibration and parameterization, analysis of the dimensions of quantities in the model, the fact that this represents a count of persons, this other value is persons per time, etc. And we're going to be talking about some best practices in model building. In the meantime, we're going to be introducing a bunch of analytic tools which help us understand these models, including things like state space or phase space-based characterization of systems, depicting them in terms of stocks and flows, regardless of how they're implemented under the covers, and ways in which we can use those tools to gain better insight into why we see system behavior of the sort that we did. So this class is going to be fairly informal. You'll find me giving lectures, to be sure, but a lot of it will be interactive. I'm going to be asking you folks every lecture just about to follow along with exercises on computers. For those who want to bring their own laptops, that's great. You can follow on your own laptops. For others, if you want to depend on these computers in the room, all of them have the requisite software installed, AnyLogic PLE, Personal Learning Edition. And I would urge you to come early for obvious reasons. We're an overflow here. And we're going to need to economize on the machines that are available here, okay? I've given you a schedule that's very detailed in terms of the very particular concepts covered in each lecture for different lectures during the term. That schedule is provisional in the sense that I'm going to be gearing it based on how fast people seem to be coming up to speed on certain concepts, what things are drawing a lot of questions so that we need to spend more time with them, etc. So I'm not going to promise that I live by that exactly, but what I will tell you is that also in the syllabus I have a specification of the due dates for assignments, and I expect those to be quite precise in terms of the timing, although the exact content of them will be varied. The class will have a very strong project component. How many people in this room are here for CMPT 858, the graduate version of this class? Okay? So for the graduates in the room, you can anticipate a wholesale focus on projects as part of this course. And you will be shortchanging yourself if you don't put quite a bit of energy into those projects. There will be some additional learning also in the form of problem sets, etc. But it's really in the projects you gain the most understanding. For the others in the room, those who are undergraduates, there's also going to be a significant opportunity to engage in projects with some constraints and provisos I'll come to. The course will be demanding, and it's going to be highly interdisciplinary. There's quite a few people in this room who are not coming from computer science background, and a large mass that are. I'm going to try to, within my lectures, speak to both groups, and if necessary, I'll hold separate sessions to brief certain groups on elements that the other takes for granted. Now, for the past few years, and the trend towards it is reinforced this year, we're going to be making use of a flipped classroom. If others want chairs, they're up here in the front. There's quite a few chairs up here in the front for anyone out there in the hallway too, okay? So we're going to have what's called a flipped classroom experience. What that means is I'm going to ask you as a fundamental component of the marks for this course to pursue some take-home challenges, okay? I want you to take on these exercises and struggle with them a bit. Personally, I'm not going to mark you higher if you solve the exercise versus not. The point is to struggle with it. to make a genuine effort to try to focus yourself on solving it. Even if you fall short, that won't be taken against you. The goal of that is to get you to think things through, so when we come together as a class, you'll be able to appreciate the points of learning, how it's solved in class, or the important points that give you the pointer to that solution, okay? So I need you to take these seriously. And for the undergrads, I think it's something like 24% of the mark is on these things, okay? There will be many of them, something like 10, 11, 12 of them during the term, okay? And I need you to take them seriously. Remember, it's not like you absolutely have to solve them, but spend at least an hour working with it, even if you can't solve it. This course mixes an emphasis on deeper concepts, things like emergence and path dependence and concepts underlying our understanding of state space and equilibria, etc., with some very practical skills with a particular software package called AnyLogic. I neither have the time nor the inclination to shortchange the coverage of concepts so as to teach every little element of how to use AnyLogic. You will find literally thousands of videos online with me leading them, going through exercises with AnyLogic, solving different problems and so on. There is a huge number of resources out there, including many by myself, out there on YouTube, which you can make use of. And I will be asking you to make use of those to solve some of the problems. This is not a training course. It's a course about the concepts of simulation modeling and how they can be applied in practice using AnyLogic as a tool. So I will require some maturity in sort of figuring out when you need to go out and find things. Of course, you can ask me in office hours. I'm perfectly happy to show you in office hours how you do things. That's great. That will be fun. Just don't anticipate that every lecture will be teaching you every single step that is needed to solve a given problem. I particularly say this for people not from computer science background, as well as some of those from computer science background on the math side, okay? So we're going to try to use class time for the unique things we get by coming together. Not just me regurgitating material, which you can find online, but addressing questions, difficulties, discussion of the implication and application to areas of interest, exploration of some more advanced topics, discussion of real-world modeling projects, etc. Okay. Now, I want to make clear, particularly with such a full class, judging by what I saw earlier, there may be a few people outside who are not able to be in here, or feel they can't because of the crowding. This class is not for everyone. Okay. This class has a rigor to it in terms of what I expect in terms of understanding mathematics and understanding some aspects of computational problem solving that mean that it can be quite demanding for people who don't feel strong comfort in these areas. I particularly highlight mathematics and statistics as something that I will be drawing on. If you're feeling really, really queasy about that notion of derivatives that you learned about in first year calculus, if you really hated probability theory, you're probably not best suited to this class. Okay. This class requires us to use a certain rigor in analyzing real-world systems, and elements of calculus, elements of probability and statistics are part of the toolbox we'll be using. And I'll be looking to you to deliver on those things with a certain measure of comfort from the get-go. That doesn't mean I'm going to be presenting things at a sky-high level. I'll actually try to make it very intuitive and bring it home. But if you're feeling some amount of real dislike for those subjects, or you feel very, very weak in it, you should really reconsider, because this course is demanding in these areas. For those people from different backgrounds, there are some people in here from health and policy sciences, some people from engineering, others from computer science, and each group is going to have to accommodate to the needs of the other. In computer science, Traditionally, we don't spend a lot of time characterizing real-world systems. In engineering, that's a lot of what we do. In physics, we characterize whether planetary systems or molecular interactions or atomic level phenomena, we characterize it. But in computer science, a lot of computer scientists go through the first few years of training with a very inward focus on the details of the algorithms and so on. There's some benefits that can come from that. But here we are dealing with characterizing systems in the world, and it requires a different type of thinking. And I need people who are comfortable with this. Okay. I will be presenting, of necessity, when you illustrate simulation principles, you apply them to certain areas. They're applied to a certain problem. Most of my problems in this class, by no means all, but most are drawn from the health area. Okay? It's an area to which I contribute with these tools and where there's a huge demand for these sort of tools. I would ask, if people are not open to learning something, a little bit about other domains, a little bit about the terminology, again, it's probably not the best class for you. Okay? And I would suggest that students are uncertain. Consider looking elsewhere, review some of the videos from last year perhaps, which are all online, and figure out if it's a good match. Okay? Okay, so a key resource for this class is going to be the Moodle site. Those in computer science are almost with uniformity familiar with Moodle. If you're not, you can go to moodle.cs and you can check out the course site there. I have a very detailed syllabus posted there. I think it's upwards of 10 pages. And again, with lecture by lecture, concepts covered, etc. I also have a wide variety of resources linked to there, including broad sets of videos from past years or from past training sessions, etc. So I would suggest that you go there. Those not from computer science background, I understand that that there's a need to log in a very first time to Moodle for certain processes to happen. So you're going to want to do that as soon as possible. For example, I can't add someone as an attendee of the course unless they've logged into Moodle before, because it doesn't know about them on campus. Okay. So please, everyone, if you're going to continue in the course, please try to log into moodle.cs.usask, and we'll get you going. Okay. I hold office hours after every class of this, except today, as the very first day, in breakout rooms. And my secretary arranges one of the breakout rooms for us. It's typically a pre-specified one, and I happen to not know if it's 342 this year or 371, but it's one of the rooms, one of the breakout rooms right over there. And I typically am there for an hour and a half to answer student questions, talk with them about the material, go over student project, progress, etc. That's my commitment to this course. And on demand, I will give tutorials. And almost always I have one or more review sessions for this course. So what am I expecting for this course? I do expect participation. Because of the flipped classroom experience, being able to follow along in the classroom for some of the interactive exercises we'll be pursuing is important. Having a dialogue about certain things can also be important. So despite the packed nature of this room, I'd like to encourage that. As I said, I expect you to view some online materials, and there will be these take-home challenges that are pass-fail. You pass if it looks like you really engaged and struggled with it some, or if you solved it as part of that, great. If you didn't, great too if you struggled with it. There'll be 4 assignments. Okay? For graduate students, and selected undergrads, there will be an opportunity to pursue projects instead of the assignments. Graduate students can also pursue them in addition to the assignments. sort of hedge their bets, okay? For undergrads, there's an exam for the course. It's not required for graduate students, okay? If a graduate student wants to take it, I'm happy to oblige, and you'll probably learn something. We'll certainly be having review sessions that will be of interest, very likely, to the grads, because they kind of sum up a lot of things, bring things together, and answer questions. And I noted sort of a need to be open to willingness. Okay, I've delineated in the syllabus 2 marking schemes for each of undergraduates and graduate students, okay? And you should go through those carefully to figure out which of them you wish to elect, okay? By default, I assume scheme 1 for each, but if you want to make use of the other scheme, you should let me know. Okay, projects. Projects in this course are different from what you've pursued in many other courses. If I had to point to them being similar to another course, the close to which they evince closest similarity is my course, CMPT 371. How many people in here have taken 371? Okay, I salute you. That's great. So you will know in 371, for recent years, there's been a requirement to pursue projects in teams indeed in that course of a certain size, and secondly, to have real world stakeholders involved, okay? To have someone who cares about this who's not a student in the course. So it is in this course, okay? I seek teams of size 2 to 4, not 10, 11, as in 371, to pursue the course projects, and there is a requirement for some sort of external stakeholder who cares about it. This can't be just something you dream up and say, okay, that'll be interesting to pursue. There needs to be someone who has a bit of skin in the game and can frankly guide you a little bit with respect to it, okay? The project, I'm quite open to different things. Typically, it's a modeling application. We build a model to study something, to learn about a system of some sort that's of interest to the stakeholder. Sometimes people do methodological studies. They'll build models of a given system in 2 different ways and compare them or something along those lines. I will, by Saturday night, be posting a set of projects. We have stakeholders from around the world sending them in right now as ideas for project teams. I will be posting them. Those are not exhaustive. Each year, students come to me and say, hey, I have a supervisor, I'm a grad student, and my supervisor is interested in me doing a project like this, or that involves this area. Could you suggest something that might be, of interest to the supervisor, or the project supervisor wants them to do X, Y, Z. In other cases, students, have relatives who work in a company that does modeling of, or that's interested in modeling of some market or company dynamics or something, and they bring that problem, and that's great. That's great. I'm happy to see those taken up. But I'll also be seeding it with a bunch of project ideas that are reliable, that involve reliable stakeholders doing things which I think are sensibly sized and you may be interested in trying. They are best pursued in a team because you learn more in a team context. Upon exception, I'll talk about individual projects, okay? I will require, for the projects, a staged delivery of the projects in the course of the semester, and there's some deadlines specified there for delivery of stages 1 through 3 before the final stage. I'm also going to require this year for each of those stages that the team meet with me to at least briefly talk about your progress, okay? And I need you to turn something in from the get-go. The earliest of those dates is September 18th, which is coming up quick, right? Less than 2 weeks. Okay. The syllabus has extensive discussion of project requirements, what's sought for the final deliverable, et cetera, and I would refer you to that. Right. I won't go into it here. Okay. I mentioned classroom exercises. Depending on the crowding situation, we have a number of people in chairs here. Depending on the crowding situation, it's possible we'll need what's called the mobile lab. Okay? I'll tell you a secret. This class was slated to be delivered over in education, the education book. And one of the reasons we had it here was so that we could use the mobile lab if possible. The mobile lab is this big cart they push that's full of Macs, and they hand them out. And we have recourse to that. If there's people here who are inconvenienced or disadvantaged by the fact they don't have a machine to access, number one. Number two, they don't have a laptop. We'll need to deal with this, okay? So the mobile lab is something we can call on, and I need you to tell me, if you're stuck, you don't have access to a machine with the software here. I'll make that a priority, and they'll roll it down the hall instead of to education. Took a lot of effort to get it back in this classroom. Okay. So office hours, I said Sphinx 3 and 6, it may be there, maybe 342, maybe 371. And I mentioned the course location. Okay, so what do I need you to do before next time if you have a laptop? Well, if you have a laptop, if you want to run the software on your laptop, which is a great experience, you will need to go to this address, www.anylogic.com/downloads, and download something called AnyLogic PLE for your appropriate platform. Windows, Linux, Mac, all supported. Download 8.1.0 of that. It'll be fairly important that we all standardize, or else it's going to cause issues when I look at your models, you look at my models, and stuff like that. AnyLogic is uncomfortably picky about sort of model version. Okay? So you can go there, download AnyLogic PLE, but it's also on all these machines and the machines out in the lab. These machines are reasonably powerful, so they should make a good experience. Now, again, given the large number of non-CS people here, I'm told that non-CS people who are registered currently for this course can log into these machines here. If you are not from CS and you cannot log into one of these machines and you are registered for the course, please, please, please tell me as soon as possible so that we can get the tech staff to straighten it out. Because once again, using the machines in class starting in about 5 minutes will be very important. Okay? Okay, great. Maybe not, maybe 5 is an overestimate. Okay, so that was a little bit about the course. Any questions before I dive into a first hands-on, concrete glimpse of the sort of models we'll be working with during the semester? Any questions I can answer about administrative about the course? Going once? Going twice? Yes, yes, no. Yeah, the assignments, great question. The assignments will be posted on Moodle. And you'll see them appear. I typically try to do that at least 2 weeks ahead of when they're due, preferably more. And the submission will also occur on Moodle. I'd like you to be very careful about that. Unless there's an extenuating circumstance, please don't send your assignments to me via mail, because I get many pieces of email, and I don't want it to get lost in the shuffle. So please try to submit, if at all possible, all the elements of the course. This includes project-related stuff and so on via Moodle. If there's extenuating circumstances, Moodle's not working or whatever, let me know and I'll work with you on that. But otherwise, it's all through Moodle. Good question. Other questions? Okay. Great. So, yes. One thing I didn't say here, and I should have. Ladies and gentlemen, I have a long-time habit, for the sake of my students predominantly, of recording screencasts of all of my videos. this semester, we're going to be attempting to reliably record more than screencasts. We're going to be recording videos of the board together with together with sort of me as a lecturer and my screencast together. This is experimental. We're going to give it a shot here. There's a thing up there that is going to be a video camera that is going to be imaging me, etc. So I would suggest that you be aware of these and you make use of them. By the same token, last year's courses are predominantly available in terms of video form, and you may want to make use of them as well. Okay. So here we go, and I'm going to, in fact, I'm initiating the recording. Okay. And I will be posting these hopefully within a day for the screencast ones to YouTube for your browsing pleasure.